Hello Honors Pre-Calculus students, Mr. Guzzato. Today's learning target is to compose inverse trig functions, and we're going to use this worksheet. This will be video examples of our class notes. I'm not going to go in order, so I'm going to go to problem number 6. And if you remember from first semester, if I had f of g of x, we always started with the inside function. So if you look at problem number 6, we're going to start with inverse cosine of a half. So if I think of this as cosine inverse of half is equal to some angle like we did yesterday, this means the cosine of some angle is 1/2. Inverse cosine, remember the range is 0 to pi. Therefore, when we draw this picture, we're restricted to quadrants 1 and 2. Cosine refers to the x value. So this is the diagram. And the angle, the reference angle is pi over 3, so the angle is 2 pi over 3. So this problem becomes the sine of 2 pi over 3. And we actually could use the same picture. The sine of 2 pi over 3 refers to the y value. So the final answer is root 3 over 2. So sine of inverse cosine of a half is equal to root 3 over 2. Let's take a look at problem number 7. Using the same idea, I'll start with the inside function. This means the tangent of some angle is -2. From yesterday, we know the range of inverse tangent is negative pi over 2 to pi over 2. So we have to draw this angle in quadrant 4 because it's negative. So I'm going to draw an angle there. And if I were to label the sides of the triangle, tangent is opposite over adjacent. And if you're in Miss Gilbert's class, I do not put the negatives on my triangle because distances are positive. Using Pythagorean theorem, we'll get the hypotenuse is the square root of 5. So this is the angle there. So this problem then becomes the cosecant of that angle. And remember, cosecant is defined to be the hypotenuse over the y value. And the y value is -2. So the final answer for problem number 7, the cosecant of inverse tangent of -2 is equal to negative root 5 over 2. So if you were to compare problem 6 and 7, number 6 uses the unit circle values that you're familiar with. Problem number 7, you had to draw a right triangle and label the sides of a triangle. If you want to pause problem number 8 and try it on your own, you feel free to do that. Otherwise, continue to watch the video. So for problem number 8, I need to find the sine of 7 pi over 6. So I'm going to draw a picture. I know some of you have that memorized. So 7 pi over 6 is in quadrant 3. Here's the angle. The reference angle is pi over 6. I'm going to drop the altitude. We have 1/2, root 3 over 2, and 1. So this problem becomes inverse cosine. The sine of 7 pi over 6 refers to the y value, so that's -1/2. So now we have to do this problem, inverse cosine of -1/2. Again, if I think of this as some angle, this translates to cosine of some angle is -1/2. Remember, the range of inverse cosine is 0 to pi. So when I find this answer, I have to draw the angle in quadrant 2. And when I draw the angle in quadrant 2, the cosine refers to the x value. So this is the diagram. And I know some of you do not need to draw that diagram. So the reference angle there is pi over 3. So the final answer here, that angle is 2 pi over 3. So for problem number 8, the final answer is 2 pi over 3. Continuing on to problem number 9, I'm going to start with the inside again. I'm going to draw a diagram. So 2 pi over 3 is in quadrant 2. The reference angle is pi over 3. I'm going to drop the altitude and label the sides of the triangle. So we have root 3 over 2, 1/2, and 1. So this becomes the inverse tangent. Now remember, cotangent, I'm going to do this down here. The cotangent of 2 pi over 3, remember, is the x value, which is negative, over the y value, which is negative 1 over root 3. So this is inverse tangent of negative 1 over root 3. You could rationalize that. So the second part of the problem, I'm going to say, all right, that means the tangent of some angle is negative 1 over root 3. The range, again, of inverse tangent is negative pi over 2 to pi over 2. So I have to draw this diagram in quadrant 4. And when I label, the y value is 1. Again, some of you put negative 1 in your diagram. I do not. And the hypotenuse is 2. You should recognize this to be a special 30, 60, 90. The reference angle is pi over 6. And since we're going down, the final answer here is negative pi over 6. So the final answer to problem number 9 is negative pi over 6. At this point, I'm going to spiral back up to problem number 5. Again, if you want to pause the screen and try it on your own, you may. So we always start with the inside function. So this means the sine of some angle is equal to negative 2. At this point, you should remember, if you think about the sine graph, the highest the sine graph goes is 1, and the lowest it goes is negative 1. So if you think about the basic sine graph, the sine graph is trapped between negative 1 and 1. Therefore, this is undefined. Another way you could look at this problem is if you were to think about the picture, and you would want to draw that in quadrant 4, the sine is the opposite over the hypotenuse. This is not possible, therefore again, this is undefined. So the answer to number 5 is undefined. Now let's just kind of keep scrolling back up. Problem number 4. Again, we're going to draw a picture. This means the cosine of some angle is 2/3. Cosine, remember, is restricted to quadrants 1 and 2. Since it's positive, we're in quadrant 1. The adjacent is 2, the hypotenuse is 3. Using the Pythagorean theorem, 9 minus 4, you get the opposite side is the square root of 5. And then this is the angle that I'm referencing. So now this becomes the cosine of that angle. And looking at this picture, the cosine of that angle is 2/3. You'll notice that this problem, they kind of undo each other. The cosine and cosine inverse undo each other. If the problem said sine of cosine inverse of 2/3, I would use the same picture that I drew here that I'm highlighting in blue, but then the sine of cosine inverse of 2/3 would be root 5 over 3, just to show you a different type of problem we could ask. If we scroll up to problem number 3, I'm going to start with the inside function again. So I'm going to draw a diagram. Negative 2 pi over 3 is in quadrant 3. So there's the angle. The reference angle is pi over 3. I'm going to drop the altitude and label the sides of the triangle. So we have root 3 over 2, 1/2, and 1. So now this becomes inverse tangent. The tangent, remember, I'm going to do this over here, tangent of negative 2 pi over 3, remember, is the y value, which is negative, over the x value, which is negative. So this is square root of 3. So this becomes inverse tangent of square root of 3. Now, inverse tangent, remember, is restricted to the quadrants 1 and 4. So I have to draw this picture in quadrant 1. Tangent is the opposite over the adjacent, and the hypotenuse would be 2 there. You should recognize this to be a 30, 60, 90. That reference angle is pi over 3. So the final answer here is pi over 3. Now if you were to compare problem number 3 and 4, notice in number 4, cosine inverse of 2/3 undoes each other, but in problem 3 that does not happen. Notice the inverse tangent is the outside function. So now let's take a look at problem number 2. In problem number 2, I'm going to do the same idea. I'm going to start with cosine of negative 5 pi over 3. So negative 5 pi over 3 is going to bring me all the way around here to quadrant 1. So that's negative 5 pi over 3. The reference angle is pi over 3. And if I were to drop my altitude here, we have root 3 over 2, 1/2, and 1. So this problem becomes cosine inverse. The cosine of negative 5 pi over 3, remember cosine refers to the x value, is 1/2. So now you have to think the cosine of what angle gives you a half, and that answer is pi over 3. Again, notice inverse cosine of cosine negative 5 pi over 3, it does not undo each other here because of the restriction. So if you compare number 2 and 3, notice you can't just cross off or cancel inverse cosine of cosine, and in problem 3, inverse tangent of tangent. They can't just cross those off and get the answer quickly. You need to think about it visually. All right, last problem. Sine inverse of sine of negative pi over 10. So negative pi over 10 is not one of the special angles that we know, but I'm still going to draw the picture here. So that angle, suppose, is negative pi over 10. I'm going to drop the altitude. Now remember, sine refers to the y value, so I'm just going to label that y, and we do know that the y value is negative. So if you look at this particular picture, sine inverse of sine of negative pi over 10, this becomes the sine inverse of y. So the sine of what angle gives you the value of y? Well, that angle is going to be negative pi over 10. So I hope you found this video helpful on the composition of trig functions.